All right, guys. I know we're cold. Well, at least in 2025, we're cold and it's icy. I'm going to go through. I just made this. Hopefully, all these questions work out. This is some extra practice. I know we've had a lot of days off, and some of us need the extra practice. So I made this, and now I'm making a work through video. I'm going to go a little bit faster than normal. I'm not going to slow down. I'm going to do every question quickly. So if you need extra help with 30, 60, 90s and 45, 45, 90s, go watch those lesson videos so that you can really get down how to do those specifically. I'm going to be working on those, but I'm going to be doing them quickly on this video, except for like maybe just the first two. But after the first two, we're going pretty fast. All right, special rights and Pythagorean theorem. This is the majority of the points on the quiz. This is a pretty basic 30, 60, 90 triangle. A lot of students like to write this at the top of the page, 30, 60, 90, with the numbers 1, root 3, and 2, or just understanding the two rules. The two rules are the hypotenuse equals the short leg times 2, the long leg equals the short leg times root 3. Those are the two rules. I am going to apply this information quickly. So if you can't do it as fast as me, don't sweat it. But remember, you should be giving it the old geometry. Try to do this stuff in your head. Try to do these patterns without having to show work. Try to simplify this stuff without having to show work. The hope is you can eventually do what I'm doing in your head. So here we go. This is the 60-degree angle. That means that this is the long leg. To go from the long leg to the short leg, you have to divide by root 3, which would be 8 root 3 over 3. And to go from the from the short leg to the hypotenuse, you have to multiply by 2. So 8 root 3 over 3 and 16 root 3 over 3 would be the two missing sides there. Over here, this is going to be the only question I write this out on, but the rules are, and a lot of people like to put this at the top of the page, 45, 45, 90s are associated with the numbers 1, 1, and root 2. Or the one rule you have to know, the hypotenuse equals the leg times root 2. So here we have the hypotenuse. To go from the hypotenuse back to the leg, you have to divide by root 2. So the legs would be 4 root 2 each. Again, if you need to slow down and show your work to get these answers, do it. But you need to know how to do these processes. Those are the answers to this one. There's other videos that slow that down for you. Go back and watch them. Here we have a triangle. All three sides are equal. So we're going to drop it like it's height, drop it like it's height. And when we drop an altitude here, it's going to split the bottom in half. Because it's an equilateral triangle, these corners would be 60. And when we split the top in half, they become 30 and 30. So what I'm working on is a 30, 60, 90 triangle where we have a corner of 60. The hypotenuse is 14 root 7. This is basically what we've got. So if this is 30, the side across from 30 would be 14 root 7 divided by 2. And the side across from 60 would be the short leg times root 3. So 7 root 21. What is the height? 7 root 21 would be the height. So we divided by 2, and then we multiplied by the square root of 3. A square has an area of 40 units squared. Okay, well, let's think about a square for a second. All the sides are the same. The area equals the side length squared, which really it's from the rectangle. The area equals like the base times the height, except for the base and the height are all the same number. So if I call that like x, we could say that since the area equals the side squared, that 40 equals x squared, basically, because they're telling us the area. So we have to take the square root. And so what is the square root of 40? So real quick, square root of 40. How do we simplify that? We pull out perfect squares. What are the perfect squares? 1 squared is 1. 2 squared is 4, 3 squared is 9, 16, 25, 36, and then 49 is too big. 36 times 2, too big. 25 times 2, too big. 16 times 2, we're at 32, but times 3 is too big. 9 times 4 is 36, and then the next one's 45, too big. 4 times 10, there's our winner. So this is the square root of 4 times the square root of 10. Why do we do that? What is the square root of 4? It is whole number 2. That's why we only care about perfect squares. Don't just pull out any factors, pull out perfect square factors, guys. Because perfect squares, when you take the square root of them, become whole numbers. So that means the square root of 40, that is 2 root 10. So that means that each side is 2 root 10. All right. So they gave us the area. We had to take the square root to figure out how long each side was. How long is the diagonal? Well, if this is a square, that means that the corners are 90. So what we're effectively working with here is a right triangle that has 2 equal sides. That's a 45, 45, 90. So if this is 2 root 10, the hypotenuse is going to be 2 root 10 times root 2, which is 2 root 20. The rule is the hypotenuse equals the leg times root 2. Well, what is the square root of 20? There's a couple ways you could do this, but you could do what we just did. Take the square root of 20 and break it down. That would be the square root of 4 times the square root of 5. I'm going through this list in my head and figuring out what goes into 20. 4 times 5, that would be 2 root 5. But there was already a 2 in front, so it's 2 times 2 root 5, which is 4 root 5. So how long is the diagonal? Final answer for this question is 4 root 5. That's a hard question. You have to know how to do a lot of good math to get there. So I would be thinking about that and why it works and how I did all that, guys. Solve for x, y, and z. Oh, there's a lot going on here. We have 2 triangles. I see an isosceles triangle. I see a right triangle. If that's 120 degrees and these 2 sides are equal, that means these 2 corners have to be equal, so they're going to be 30 degrees each. So I see a few things I could do, but I'm going to focus on the big triangle. Let's change colors. I'm going to focus on this big triangle for a second. If this corner's 90 and this corner's 30, that means this corner has to be 60 altogether, which would make this 30, which would make this 60. Oh, and if that's 120, that has to be 60. So we got a lot going on here. So if I'm focusing just on that big right triangle with a 30 in this corner, a 60 up here, and a 90, and we know that that big hypotenuse is 42. So special right triangles, 30, 60, 90, the hypotenuse is the short leg times 2. So I'm going to divide by 2. And the long leg is the short leg times root 3. So I'm going to take the short leg and multiply it by root 3. And that would be the entire bottom. That would be z. Z is going to be 21 root 3 on this question. Now, in the process, I'll change colors again. We got this side as 21. And now we can look at this smaller triangle. So I'm going to draw that blue triangle over here where we have a 60 in this corner, a 30 at the top, and this side is 21. So for this triangle, the 21 is the long leg. Well, the long leg equals the short leg times root 3. So I need to do 21 divided by root 3, which is 7 root 3. 21 divided by root 3, I'll show it one time. That's what it looks like. You get 21 root 3 over 3, which reduces to 7 root 3. And that would make the hypotenuse 14 root 3. So what do we have here? We have the bottom x would be 7 root 3. And the hypotenuse here would be 14 root 3. And as we know, that is going to be equal to y. Those are going to be the same number. So this is also going to be 14 root 3. So our final answers here, I'll just kind of list them out. Let's put them up here at the top. X would equal 7 root 3. Y equals 14 root 3. And Z, which is the combination of those two, is 21 root 3. All of that checks out. I love it. Pretty good question there. Number 6, we got parallel lines. We got a right angle. Well, parallel lines tell us that the same side interior angles have to add up to 180, so this would also be 90. Over here, this would have to be 60. It's actually a trapezoid if you know your trapezoid properties. Trapezoids, one of the common things we're going to be doing, guys, is cutting off what I call the wings. So if we cut this wing off with a right angle, you're going to make right triangles. In this case, specifically, it would be a 30, 60, 90 right triangle. So if the hypotenuse is 14 root 21, Then the short leg would be divided by 2, 7 root 21. Huh? Didn't we just have that? Oh, we had 7 root 3. I don't know what we had. Doesn't matter. 7 root 21. Now, the long leg is going to be 7 root 21 times root 3. One way you could do this is break this down into root 7 and root 3, right? Root 21 is root 7 times root 3. Why do we do that? What is root 3 times root 3? It's whole number 3. Times 7 would be 63. No, it wouldn't. Whole number 3 times 7 would be 21. And then we would still have a root 7 on the inside. So this would be 21 root 7. Oh, that's interesting. 7 root 21 times root 3 is 21 root 7. That is fun. Huh. I haven't seen something like that really happen before. Did I do it right? Yeah. An alternative way to do it would be to call this 7 root 63. Root 63 is like root 9 times root 7, which is 3 root 7. But don't forget there was a 7 in front. So 7 times 3 is 21 root 7. And that height would be the same all the way across. So this would still be 21 root 7. What is the... Oh, I didn't give you enough information. So I will adjust this when I give you the actual file. But you would need to know like one more number. Let's say that this top is just like 15. I don't know. I'm just making something up. It really doesn't matter. Okay. So if that's 15, that would make this section also 15. And I just made this up. So when you get your paper, this will already be there. But like I said, I just made this real fast a few minutes ago, and I overlooked that. So we would need some value there to get the perimeter. So as we go around the shape, this would be 15, 14 root 21, 14 root 21, 7 root 21, another 15, and 21 root 7. Effectively, we got to add up all those outside distances. 15 plus 14 root 21 plus 7 root 21 plus 15 plus 21 root 7. So 15 and 15 would give me 30. We have 14 root 21 and 7 root 21. That would be 21 root 21. Oh, that's just so fun. And then we would have a 21 root 7 to finish it off. Those are all unlike terms. We cannot combine anything else there. All right, number 7, solve for x. We got a couple right triangles. This one we actually have some numbers on, so let's work on that one first. I would reduce and see what we got. Both of these are divisible by 5. If I divide by 5, this would be 5. Divide by 5, this would be 13. Oh, I'm loving this. So the hypotenuse is 13, so this would be a 5, 12, 13 triangle. So this would be 12 times 5. This would have to be 60. So if you know your triples, you would realize real quick. Otherwise, you'd have to do Pythagorean theorem on that. But it's a 5, 12, 13. If we divided by 5 to get small, then we have to multiply by 5 to get big again. So if that's 60, now we're working on a 45, 45, 90. And the rule is the hypotenuse equals the leg root 2. So the leg would have to be 30 root 2. So x would be 30 root 2. Perfect. Number 8, this is a bit of a challenge question. A, B, C, D is a rectangle. That means that these corners are all 90s. It means opposite sides are equal. Okay, hopefully this works out. I did just make this. If there's a problem, we'll find it. All right, so first situation. Let's go. There's 3 30-degree angles in this picture. In this triangle here, we have enough information to find the 2 missing sides. We have the side across from 30, that's the short leg. So the hypotenuse would be times 2, 18. And the long leg would be times the square root of 3, so that'd be 9 root 3. Let's shift our focus to the bottom here. On this triangle, if that's 30, this would be 60. So we have the hypotenuse, so we would divide by 2. That would be 9 root 3 over 2. The side across from 60 would be 9 root 3 over 2 times another root 3. The long leg equals the short leg times root 3. So 9 root 3 over 2 times root 3. Well, root 3 times root 3 is 3. Times 9 would be 27 over 2. So this side, DC, equals 27 over 2. All right, so we got one side of the rectangle, 27 over 2. Now we need the other side. So let's work the other direction a little bit. Let's work on this triangle. Here we have the hypotenuse, and that's also a 30, 60, 90. So 18 divided by 2, this part would be 9, which would make the long leg 9 root 3. So that's actually just like the other triangle. All right, so that means that A to D is 9 root 3. Well, the area of a rectangle, if we do that work, area equals base times height. So the area would equal the base, 27 over 2, times 9 root 3. That's like 9 root 3 over 1. We got to do 9 times 27. If I'm on the quiz and I don't have a calculator, I'm going to do 20 times 7. I can write a better 20. 20 times 7, no, 20 times 9, and 7 times 9. I'm breaking 27 into 20 and 7, and that would be 180 and 63. That's a lot easier to do, I think. So 180 plus 63 would be 243. So we have 243. Don't forget there's a root 3 over 2. Perfect. That's a hard question. Maybe I made the questions a little too hard. I don't know. It's feeling a little harder than the quiz, perhaps, but that's good practice. Pranav is building a ramp to do bicycle jumps. If he wants the ramp to make a 30-degree angle with the ground and rise 2 feet, how long will his ramp need to be? So if you don't know what's going on, draw a right triangle. That's the whole unit, right triangles. Which part of this would be the actual ramp? Do ramps go straight up and down? Nope. Do ramps go straight? No, those aren't ramps. Ramps would be the diagonal part. So the ramp is this. I want that. I want to know how long will the ramp need to be. It says it's going to rise 2 feet. Rise 2 feet. Rise would be up and down, vertical. And it says it makes a 30-degree angle with the ground. So 30 degrees with the ground. Where does the ramp meet the ground? That would be over here. If I said it makes a 30-degree angle like with the platform or whatever this is called, I don't know, then I would need to put the 30 degrees there, but I didn't. I said it makes a 30-degree angle with the ground. So the short leg is 2, so the ramp would have to be 4 feet tall, or 4 feet long. 30, 60, 90 rules. The hypotenuse equals the short leg times 2. Okay. Simplifying radicals. So we have adding and subtracting, we got division, we got multiplication. This will all be fun work. You need to know your perfect squares. I'll make a short list here, 4, 9, it's not a short list, I'll make the list. 25, 36, 49, 64, 81, 100, 121, 144, 169. That's a good list. That's a good list. So those are the numbers we're trying to figure out, hey, do they go into these radicans? And if they do, we're going to pull them out. So 48, I would start at the end and work backwards, but you're going down this list in your head. Well, 48, you'd have to start with 36 because all the other ones are already bigger, but 16 goes into 48. So this would be root 16 times 3. Well, the square root of 16 is whole number 4. And there's already a 3 in front. So this is 12 root 3. Nailed it. Next one is the square root of 40. That's the square root of 4 times the square root of 10. That's whole number 2 times 10, but there was already a 7 in front. So that's going to be 14 root 10. The next one's the square root of 27. That is the square root of 9 times the square root of 3. Why'd I pick 9? Square root of 9 is whole number 3, so that's just 3 root 3. There's nothing else to do to that. And then the square root of, ooh, that's a big number, but look, it ends in a 0, so I can divide it by 10. Pick the most obvious number first. And yeah, divided by 10 looks real nice because root 121 times root 10 is real good for us because the square root of 121 is whole number 11. Don't forget there's a 6 in front. So that would be 66 root 10. And what are our operations here? Plus, minus, minus. So combine like terms, we have 12 root 3 and 3 root 3. That is 5. Oh, we're subtracting. 12 root 3 minus 3 root 3 would be 9 root 3. And then we have 14 root 10 minus 66. So what is 66 and 14? How far apart are those? 66, 56, 52? Would be minus 52 root 10. And that would be our answer here. You can't go any further. 9 root 3 minus 52 root 10. Okay, next one. When we're doing division, you must reduce first or you're going to be in for a world of hurt. 10 and 8 reduced to 5 and 4. So let's start with that. 24 and 120. I can divide those by 12. 24 divided by 12 is 2. 120 divided by 12 is 10. And then that goes even further because 2 and 10 is 1 and 5. Oh, so I guess 24 times 5. Yeah, 24 times 5. So I did not realize 24 went into 120 right away, but I knew I could pull out a 12. So if you don't see the GCF, just pull out any common factor and keep going till you can't go no mo. So I can reduce that to a 1. Well, I'm not going to write a 1. That'd be silly. So that's 5, right? Because it's 5 root 1. Well, root 1 is just 1. 5 times 1 is 5. We're not going to write a root 1. No. And on bottom, we're left with 4 root 5 after we reduce. So here's the new problem. We need to get rid of that root 5 on bottom. This is still not considered a simplified number. I'm going to show the work, but guys, I really want you trying to do this in your head. So how do we make root 5 whole again? We multiply it by its best friend. Its best friend is root 5. Well, if we multiply the bottom by root 5, we got to multiply the top by root 5. And this becomes whole number 5 times 4 would get me 20. But wait, we can reduce again. 5 over 20 reduces to 1 over 4. There we go. So you are not done until you make it all the way to that. If you stop here, points off. You stop here, points off. And if you, oh gosh, you just missed the whole thing. To get full credit, you're making it all the way to root 5 over 4. Isn't that a much better looking number than the original? We want clean and simple as possible. Okay, multiplication, it's similar but different work. We're going to pull out the GCF, but this time we're going to multiply them instead of canceling them out, instead of dividing them. Well, another tough one. 8 goes into 32. 16 times 10. So this would be root 16 times root 2. This would be root 16 times root 10. I'm going to go ahead and take care of the whole numbers. 11 times 4 is 44. And then we pull out a GCF. Why? Because this is all multiplication, right? We're multiplying. What is root 16 times root 16? That is whole number 16. And now we have root 2 times root 10. Well, you need to keep looking. I've told you guys over and over and over, you keep looking for common factors and you keep looking for perfect square factors. Well, there's another common factor. What that means is 32 actually goes directly into 160. I just didn't realize it. But 2 and 10 have a common factor. Can't I rewrite 10 as root 2 times root 5? So root 10's gone. Why'd I do that? What is root 2 times root 2? That is whole number 2. So now those are gone, and all I'm left with is a root 5. So at the end of the day, root 32 was the common factor. 160 is 32 times 5. And if you had realized that right away, you could have gone a little bit faster. Oh, gosh, not root 2. Whole number 2. Whole number 2. All right. So I need to multiply those numbers. That doesn't look like a real easy way to do it. I'm probably going to do 44 times 16 first. So that would be 44 times 10 and 44 times 6. So that would be 440. And 44 times 6, that would break into 40 times 6 and 4 times 6. So that would be 240, and that would be 24. And we're going to add all those numbers up. So 440 plus 240 would be 680. 68704 is where we end up. And then we got to double that because it's times 2. So 1408 root 5. They won't be that big on the quiz, but you might have to multiply a couple numbers that aren't small, but it won't be this hard. And there's a chance I messed up. I'm doing it all in my head here. I'm not showing a lot of work. Hopefully I got that right. I think I probably did. Yeah, I'm feeling pretty good about that. All right. Next phase is the triangle right, acute or obtuse. And then one more little part. Oh, we got a couple little parts. Yeah, we're getting close. Quick reminders of the rules. You can go to other videos to get more in-depth information. But A plus B has to be greater than C to even be a triangle. This is always true. And then once you verify it's a triangle, there's 3 conditions. A squared plus B squared equals C squared. That's going to be a right triangle. That's the Pythagorean theorem. If C squared is smaller, that's going to be an acute triangle. Remember, as 90 degrees gets smaller, the hypotenuse would have to get smaller. And if C squared is bigger, that's going to be an obtuse triangle. As 90 degrees gets bigger, C squared gets bigger. But we don't even start doing this work if it's not a triangle. So you look at this page and it's like, okay, are they all triangles? That'd be the first thing I check. Now, remember, I did tell you guys that you don't have to check irrational numbers. That's a little bit harder. We're not doing that right now. So if they're irrational, it's going to work. We're good. But look at if they're whole numbers, you got to check them. 5 plus 4 is greater than 8, yes. 9 plus 6 is greater than 10, yes. And then this one, no. So not possible or not a triangle. So 16's out. Don't do 16. It's out. The rest of them, we got to do the second phase, which is square all the numbers. So square all the numbers. 25 squared, 4 squared, and 8 squared. Add the 2 smallest ones. That'd be 41. So C squared is bigger. It's going to be obtuse. So if the biggest one's bigger at the end, it's going to be obtuse. Over here, square the numbers. 36, 100, 81. Add the 2 smallest. 80 plus 30, 110. 117 is that. And then C squared's 100. So if C squared's smaller, it's going to be acute. And then square the numbers. Remember that this, I'm going to write it a few different ways just to remind you. This is like 3 root 7 times 3 root 7, which is like 3 squared times root 7 squared, which is like 9 times 7. It ends up being 63. So I think about it like this just right away. I square both numbers right away. So here, this would be 9 times 11, 99. And then square that, that would be 36. So we add the 2 smallest numbers, 63 and 36. That would be 99. And that's also 99. So those are equal. And that's going to be a right triangle. So that's about 20 points on the quiz, if I remember correctly. Make sure we can do those processes. State the triple, the scale factor, and the length of the missing side. So state the triple, whoop, the scale factor, whoop, and the missing side. That's what we're going to do. And we're going to have fun doing it because it's geometry. Right, guys? Right, Shivangi? Right, Shivangi. Okay. Here we go. These would be hard to do if you don't reduce. So I'm going to draw a smaller similar triangle where I reduce, and those are divisible by 10. 17 divided by 10, 15 divided by 10, and that's an 8, 15, 17. You do need to know your triples. The scale factor was 10, and if I multiply the 10 back on, 80 is the missing side. So this side would equal 80. Over here, same idea. I'm going to draw a smaller similar triangle. Oh, it's facing a different way. Got me. I got myself. I made this. I'm going to draw a smaller, similar triangle. What goes into those? 8 for sure. 8. No, not 8 at all. Okay, divide by 2, 16 and 30, 4. Divide by 4. Oh, 4. Divide by 4. 32 divided by 4 would be 8. 16 divided by 4 would be 15. Well, see, I made this quickly, and I used the same triple both times. Oh, wells. But this would be 17. 17 times 4 would be 40, plus 28 would be 68. So this missing side would be 68. Okay, might want to take a second, write all the triples. Just pause and do it real fast. But 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17 are the most common triples. Bonus points, bonus points. Who knows the bonus one? 9, 40, 41. But you need to know these for sure. Think of some system to get them down. One of the things I've showed you is it's odd, 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 even for your starting number. Sometimes that helps. If you know the starting number, sometimes it kicks into gear what the other ones are. All right, we got 1, 2. Oh, yeah, we got a couple more pages. Find the missing side. So these could be clumped together a little bit, but these use triples, and I don't think these will. But it's the same process. We're going to draw a smaller right triangle. This one go away. We can divide by 11. That would be 9. Divided by 11 would be 8. And that's not a triple. So we're going to hit it with a Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. Well, we know the hypotenuse. So we're going to say b squared equals c squared minus a squared. Cancel out the square. It's going to be the square root of it. So if you have the hypotenuse, you're going to always do the square root of c squared minus a squared. Well, that's going to be 81 minus 64 plus 7 plus 10, square root of 17. Now we divided by, so this is the square root of 17. We divided by 11 to get there, so we need to multiply by 11 to go back home. So Pythagorean theorem on the smaller numbers. If you try to do it over here, you're going to, good luck. All right, draw a smaller similar triangle. We've got 63, 39. Divided by 9 would be 7. Divided by 9 would be 4. Love it. This time we have the legs, so it's just the square root of a squared plus b squared, which is 49 plus 16. 49, 59, 49, 65. So that's the square root of 65. Now that's kind of a funky number. Let's check that out. What is 5 times what? Be 5 times 13. Yeah, so there's no perfect square factors. We would have to simplify that if possible, but it does not simplify. So we divided by 9 to get there. So we multiply by 9 to go back home. Perfect. Right, 49, 59, 65. Yeah, I like it. Extra, extreme bonus to test the best. Should I show you how to do it? I said if anyone can do it, email me, but if I show you, then that kind of throws that off. Hard question. My expectation is that probably no one can do it. I would love to see if anyone can. What do I do here? This is the snowman my family made. It's a little bit dirty. I almost died rolling those giant snowballs. Like literally, I had to sit down and rest for like 30 minutes before I felt normal again. I was extremely. I overdid it. I'm old. What do we do? Should I show you? I can't. Not yet. This is a bonus to test the best. This is not for everyone. If the rest of this was easy for you, you can try this one. You're trying to solve for x. It takes extremely high level ability on what we've learned here, but also on what we have done, what other skills you've learned in algebra. So I will maybe make another video with it, but I don't want to put it in this video. All right, that's it. I'll see you guys later.